This is the second flip-flops video and the second one on the RS flip-flop. I'm going to introduce the concept of the waveform. For this assignment, I would like you to construct the circuit that you see below, which is an RS flip-flop, and test the circuit using two LEDs to represent the outputs Q and Q0. Typically with the normal output, which is denoted by the Q, is a green LED and the Q0 is a red LED. You can use input switches, slide switches, or you can use buttons to represent the inputs. If you prefer, that's probably easier than using a loose wire. And when you're finished, I want you to test all of these inputs and these modes of operation, particularly the set to hold and the reset to hold states, so that you can see that hold mode of operation working effectively. And then you can even try the prohibited state to get the Q and the Q not to turn on, so that you see that it's really not a state or a set of inputs that you want to use at all. Let's introduce the topic of waveforms. Waveforms, or as they're sometimes called, timing diagrams, are a way to illustrate the relationship between voltage and timing. And when inputs are changed, how does that affect the output over time? So at the bottom here we see this pulse train, and we note that the vertical distance represents the voltage and the horizontal distance represents the time. The voltage we know as a 1 or a 0 corresponds to 6 volts, positive 6 volts, which is represented by our 4 AA batteries on our circuit, or the 0 volts down here, which is represented by 0, or binary 0 or binary 1. On or off, high or low, however you want to say it. Now, one clock cycle is represented by a rising edge and a falling edge. So you see that this one clock that you see here has started with a rising edge. It goes right from here, it starts, and then it goes up, and then it goes across. It's on for some period of time, and then it comes back down to the 0 position. So that is one cycle, or one clock cycle. We're going to look at several waveforms for all different flip-flops. This is an example for an RS flip-flop. And you see up here we have our S and R inputs, and below that we have Q and Q0. So we want to solve for outputs Q and Q0 based on these timing diagrams, or these waveforms. You can see over time how they change. The S we can see here starts as a 0, and the R starts as a 1. And you can see that they change at the same time. The S actually goes to a 1, R goes to a 0. So if we want to solve for Q and Q0, it's actually a lot easier if we insert these vertical dotted lines where these changes occur. And since this is an asynchronous flip-flop, we're going to insert these dotted lines at these points where they change. It just so happens that R and S change at the same time here, so they're sharing that dotted line. The next change occurs when R goes from 0 to 1, and the next change occurs when S goes from 1 to 0, and then back up to 1. So I'd like you to pause the video at this point and use the truth table for an RS flip-flop to solve for Q and Q0. And when you're done, unpause, and we'll take it up. Maybe to get you started, I can show you first the very first stage here. S being 0 and R being 1, if you look at the truth table, what state or what mode of operation is that? That would be the set state. Right, so the set state means that Q is 1 and Q0 is 0. So we see that Q is 1, Q0 is 0. Right at this point, S goes to 1 and R goes to 0. So we are in what state then? We are in the reset state. So you can see how the Q changes to 0, which is denoted by the reset state. So pause the video, see if you can finish the rest. Alright, resuming back to our solution, we see here that S is still at 1, and R is going back up to 1. Well, that's going from a reset state up to, what's a 1, 1? A hold state. So that means that whatever Q was before and whatever Q naught was before, it just stays the same. And it stays at 1 and 0, or 0 and 1, respectively. S, you can see, goes right down to 0 at this point, and R stays at 1. So what state do we have there? Right, we have the set state. We're back to the very beginning. And then finally, S goes up to 1, and R is already at 1 again. We're going back to the hold state. The hold state is whatever Q was in the previous state and whatever Q naught was in the previous state, which are 1 and 0 respectively. Since we don't have any other further changes to that timing diagram, then it just remains as you see it. Q is 1 and Q naught is 0, which is the set state. I'd like you to continue on with finishing the waveform for an RS flip-flop, which is on the RS flip-flop worksheet.